Hello class, last time we learned the inspection methods and the techniques of thick plates, thin plates, and composite plates. In this lesson, I will teach you the production process of forgings and the types of common defects in forgings. Forging is a collective term for forging and stamping. It's a process that uses as hammerhead, anvil block, punch-up forging machine, or a die to apply pressure to the blank or product plastic deformation to obtain the desired shape and size by parts forming processing method. This process method and the rolling we mentioned earlier belong to plastic processing. The process of forging is a heat treatment process. Usually, we call the blanks of parts with specified shape and size formed by the pressure of the forging hammer or die as forgings. The research and development of large-scale equipment, as well as the manufacturing of large-scale equipment, is an important sign of a country's industrial strength, and it also symbolizes the comprehensive national strength of a country. In the field of large-scale die forging processes, the 80,000-ton large-scale die forging press, which is independently designed, manufactured, installed, and commissioned by China Zhong, have made China the country with the highest level of die forging equipment in the world. The production process of forgings. The process flow starts with blanking the forging. In the blanking process, the original blank is prepared according to the specifications and dimensions as required for forging. If necessary, the original blank is also subjected to rust removal, surface defect removal, anti-oxidation and lubrication treatment. Heating forging blanks. The heating process heats the original blank according to the heating temperature and the production cycle required for forging deformation. Forging deformation process, offsetting, drawing, punching, cutting, bending, torsion, offset, and forging, and so on. The process after forging deformation, as the forging deformation is done, is followed by the cooling process of the forging. And next, in order to supplement the deficiencies of the previous process, and make the forging fully meet the requirements of the forging product drawing, it is also necessary to carry out a series of processes such as trimming and punching, heat treatment, calibration, and surface cleaning. Sometimes the post-forging cooling and heat treatment are closely combined to obtain specific forging properties. Quality inspection is carried out between each process and before the forgings leave the factory. The inspection items include aggregate shape and size, surface quality, metallic structure, and mechanical properties, etc., which are determined according to the requirements of semi-finished products and forgings between the processes. After repeated forging in this way, not only the grains in the material become finer, but also the orientation, shape, and distribution of defects are significantly affected by the amount of deformation and the direction of the deformation. Therefore, the defects in forgings are mostly area-shaped and elongated. For example, after the die forging is forged, a relatively obvious forging stream line will be formed inside the forging, and the forging streamline will make the metal properties anisotropic. The tensile strength in the line direction is higher, while the tensile strength in the line direction is lower. Generally speaking, the direction of forging defects is parallel with the forging streamline. 2. Common defect types in forgings. There are various types of defects in forgings, and the mechanism of their formation is also complicated. To fully find these defects, a variety of inspection methods ought to be taken. Among them, the defects that can be found by ultrasonic testing can be divided into two categories according to their forming process. The first category is the defects formed in the smelting and casting. During the casting process, after the metal is poured into the mold, Its solidification sequence is gradually carried out from the periphery to the center and from the bottom upwards. The volume shrinks during the solidification and the cooling process. If the metal cannot be replenished at any time during the solidification process, the final solidified part will be a cavity is formed, which produces a shrinkage cavity. If the shrinkage cavity is serious and a large length is formed, it is called a shrinkage tube. During the forging process, the metal is deformed by forging. If the shrinkage cavity is not forged after forging, it is no longer the original shrinkage cavity shape, and it is likely to change from volume defects to area defects. Casting porosity defects often coexist with the shrinkage cavities, and the reason for its formation is the rapid solidification of the liquid metal. The metal cannot produce concentrated volume shrinkage, thus forming small cavities that are dispersed and distributed. After forging, the porosity can be improved to different degrees. Inclusions can be divided into metallic inclusions and non-metallic inclusions, according to the nature of the inclusions. Metal inclusions are defects formed by adding more alloys with larger size during the metal smelting process, or by splashing dissimilar metals during casting and then not melting. Non-metallic inclusions are divided into internal non-metallic inclusions and external non-metallic inclusions. There are two segregation regions formed by internal non-metallic inclusions in forgings. One is dense in the center of the forging to form central inclusions, and the other is away from the center of the forging part, forming a square segregation. Foreign non-metallic inclusions are refractory materials or impurities mixed in during the smelting process. Such inclusions are bulky and often appear at the bottom of the ingot. The second category is the defects formed during the forging and heat treatment. White spots are small cracks caused by the presence of hydrogen. When the white spots appear at a plane perpendicular to the stress on the forging, it will cause the forging to break suddenly. The white spots are formed in different positions in the forgings. For small section forgings, they are generally formed in the center, while large section forgings are heated and cooled slowly, and the white spots are radically distributed in a certain depth range of the forging circumference. Cracks are relatively common in forgings, and there are many reasons for their formation. There are many metallurgical defects formed during the forging and cracks formed during heat treatment. The most typical example in the pictures is the central forging crack. Folding mostly occurs at the fillet and the sharp corners of forgings, and folding is a defect formed because the protruding part of the hot metal is folded and pressed into the surface of the forging. In this lesson, we learned the production process of forgings and the common defects of forgings. Only by knowing the formation mechanism and occurrences position of common defects in forgings can we effectively identify the defects echo signals. That's all for this lesson. See you next time.